So hi and welcome everybody to the beginner tutorial to the Open RAN system. In today's lecture, we will talk mainly about Open RAN, the current deployed RAN systems, Open RAN system, the differences of Open RAN from the currently deployed RAN system. Let's call them closed RAN systems, virtual RAN, the similarities and differences between them, the benefits of Open RAN, the challenges that Open RAN is facing, the ecosystem around Open RAN, the companies who are involved in this, their number and what they are doing, the deployments around the world, and radio RAN intelligent controller and the structure of the Open RAN system, and distributed unit, centralized unit, and the split between them and the other components. And then finally give some conclusion remarks and recommendations so that you learn how to build your own 5G private network for enterprises worldwide. So Open RAN vision. So let's start with the classical network appliance approach. So in this approach, you have fragmented purpose-built hardware. It was all about hardware-driven solutions. So this is it. Current RAN systems is around this kind of approach, purpose-built hardware. So you design hardware for any functionality you need to add to your network. Second, it's physical install per appliance per site. Each site, if you want to integrate or add this an additionally new functionality to your RAN infrastructure, you need to add this functionality to each site, per site. Hardware development rather than software development, which can bring large barrier to entry for new vendors, constraining innovation and stifling competition. So almost no competition, no innovation. There are a handful of vendors and suppliers for telecommunication equipment. Example of these current conventional traditional suppliers are Ericsson, Huawei, Nokia, ZTE, Cisco, Siemens, and those companies. And it's the entry level for any new company to get into this business is very hard, very tough. But like the network functions virtualization approach is a new concept that's built on top of commercial off-the-shelf hardware, and this automatically allows vendor to get standardized hardware servers at much lower cost, which automatically can result in best quality to install systems. Second, vendors could focus on softwares instead of purpose-built hardware. So you are gonna be focusing all your solutions, your excellence, your intelligence, your innovation in terms of methods, techniques, transmission schemes, and designs are gonna be implementable in software instead of implementing them in hardware, which is handy, can drive the cost to be low, and can have more impact because you can deploy it. You can just develop it once and repeat it infinity number of times, deploy it wherever you want. And this kind of approach creates competitive and innovative open ecosystem. And this approach can also lead to automatic orchestration and remote installation, especially with the help of machine learning and artificial intelligence tools. So the contemporary RAN, the RAN that's currently being deployed in most wireless systems in the world is this RAN. You have the cellular site, which contains antennas here. You have the antennas connected via cables with the remote radio unit, which includes DAC and ADAC, digital to analog converter and analog to digital converter, with some RF equipment. And you have here some interfaces to connect it with the BB unit, which is the baseband unit. The interface here is called CPRI, and it's connected with the baseband unit via fiber cable. And the baseband unit, at the baseband unit, you have the signal processing of the communication techniques, the network access, the fiber optic cablings, and all these other functionalities. What's the problem with this kind of RAN? The problem is this: the remote radio unit is proprietary hardware, which means that it's company-based, driven. Each company has its own remote radio unit, which is not compatible with any other base station or interface. And the baseband unit is also proprietary, and the software is proprietary. So everything is proprietary, which means that this is a closed system. Not anybody can get into it and make his product or services or software compatible with the product that you may install for building a base station. And even the interface is proprietary. It's not compatible with hardware, with other hardware and software devices. This means that each vendor, each supplier has his own complete full solution from remote radio unit to baseband unit as one package. You cannot buy remote radio unit from a company and baseband unit from another company. You need to buy them as one package from one single company. And this what makes a company, an operator locked in, because you don't have this freedom of choosing different hardwares based on features, based on capabilities, or even use different softwares. And this is bad. This is not good. This is bad. Not open. The cost is high. No innovation. No competition, and the ecosystem around it is very limited. So let's get rid of this, the industry said, and let's build something called virtual RAN. So what's virtual RAN? Virtual RAN is just like, think of this like the previous RAN system, but the new additional thing here, you don't have hardware-based baseband unit or just like proprietary based hardware unit. You have the baseband unit is gonna be deployed. Its functionalities are gonna be working on commercial off-the-shelf server. So you buy it from normal vendors on the market. But still, in this virtual RAN approach, you still have proprietary hardware and proprietary interface, which makes it not exciting, not attractive, and and the cost of it is not gonna be significantly different from the contemporary RAN. So this is kind of just for virtualization purposes, the software, the commercial off-the-shelf server plus proprietary software with virtualized functions. So this is also not good because vRAN is not fully open and is completely different than Open RAN. So let's move on and see what Open RAN is. So Open RAN, you have everything is almost not proprietary. It's general public purpose hardware devices, commercial off-the-shelf hardware, can be purchased from any original design manufacturer or equipment manufacturer, and the same applies to the interfaces. The interface is also open. Any vendor software can work on this hardware. This is very important statement. Any vendor software can work on this hardware. And you have also the baseband unit, which also can be built using commercial off-shelf the server device. The only thing that companies will be selling and distributing is the software which is running on top of the baseband unit. That, I mean, in terms of, let's say, proprietary, the software that's running the baseband unit is going to be the solution that companies sell to operators. But the other components are gonna be available in the market. You buy them just like the way you buy a server. The hardware, which is the radio remote unit, is open. Commercial off-the-shelf hardware can be purchased from any vendor. The interface is open. Anybody can have anything to connect with. And the baseband unit is also like a server, but you need to have the intelligence and everything is pushed to the software so that you buy the software from these vendors and enjoy the benefits that the network will have. So this is Open RAN. So the main difference is in the following 3 points. Remote radio unit, the radio, the PP unit, and in terms of software and hardware. So the contemporary RAN, if you look at the left-hand side of this slide, the contemporary RAN is this. You have vendor 1 that provides radio. You have also the same vendor that provides BP software and the same vendor that provides the PPU hardware. So as you can see, there is no ability to mix and match different components from different vendors in the legacy RAN approach. While in the Open RAN approach, which is a wireless revolution's approach, you can buy a solution for the radio from vendor 1. And the interface, you buy it from vendor 2, another vendor. And from vendor 3, you can buy the PP unit, the hardware. You can buy, this is one case, you can go with it. The other case is like you buy the PPU from vendor 1, and let's say the open interface from vendor 3, and commercial off-the-shelf based hardware from vendor 3. So now one might say, what's the benefit of this? Why do we care about this, and what are the implications? So the most important thing is driving cost down. So you will enjoy low capital expenditure and low operational expenditure, which is significant because you will be able to offer your services to your customer at a very competitive price. Second, you will be avoiding being logged in to one single vendor, because at the end of the day, he puts you in the jail. You cannot move on, shift, replace, redesign. You are stuck with one vendor for the rest of your life, and your innovation is limited with the innovation of this vendor. Your new features, it's not up to you as an operator to add new features to your network if the vendor doesn't have these features. So it means that if you are currently operating with vendor 1 for the radio and you hear about a new vendor that provides better radio than vendor 1, you go with vendor 2. Automatically you just go to vendor 2 and tell him, hey, I want to buy your radio because I heard that your radio can provide advanced beamforming capabilities. Just comes to the network, replace vendor 1's radio with vendor 2's radio, and you just enjoy the seamless, you enjoy the new additional advantages and features of vendor 2 without worrying about any compatibility issues with vendor 2 and vendor 3. You just plug and play, remove it and place a new hardware in top of the old one, instead of the old one, I mean. So this is amazing, and if we want to find what Open RAN ecosystem here, the Open RAN is a word you might hear it from different communities, from different organizations around the world, and you can read it in papers, hear it in some videos on the internet. So it's very good to understand the meaning, the original meaning behind Open RAN. So the Open RAN ecosystem is composed of two branches. One branch or one one direction is coming from the Open RAN project group that's part of Telecom Infra project, which is a community, a consortium that's consisting of hundreds of companies and organizations around the world, gathered together in order to build and deploy fully programmable RAN solution based on general purpose hardware devices, commercial off-the-shelf systems, and disaggregate software from the hardware. Why this is needed? So that operators and vendors can benefit from the flexibility and faster pace of the innovation capable with software-driven development. So Open RAN means a project group under the umbrella of Telecom Infra project community or consortium. This is Open RAN. We have the current ORAN, the ORAN alliance, which was composed of two different alliances. The CRAN alliance, which mainly I think this alliance has mainly Chinese enterprises, and the XRAN Forum, which has mainly American enterprises. The integration of these two alliances ended up generating Open RAN Alliance. And the founding members of this alliance are mostly operators, including AT&T, China Mobile, Telecom Entity, Docomo, and Orange. The key principles of the Open RAN Alliance include the following. First, leading the industry towards open, interoperable interfaces, RAN virtualization, and big data and AI-enabled RAN intelligence. Second, maximizing the use of common off-the-shelf hardware and merchant silicon and minimizing proprietary hardware. You don't need proprietary hardware. You need to have all your innovation, all your solution, all your services and the products in terms of software. Specializing APIs. APIs is an acronym that we frequently use in software development, application programming interface. It means this. So this basically gives you the ability to transfer data from one application to another via an interface that's programmable. You program it, you connect the database of application 1 with the database of application 2, and you transfer the data between them seamlessly, and you make them compatible with each other, working with each other. Now, this is something we know in software development and the software community aware of it, but like in telecom industry, we don't have such a term. So they want to bring this into the ecosystem of Open RAN and make things compatible with each other and seamlessly connected without worrying about compatibility issues. So specifying API and interfaces, driving standards to adopt them as appropriate, and exploring open source where appropriate. Why exploring open source? Because the main goal, one of the main reasons going behind Open RAN to make things, to make products at very low prices, very cost-effective solutions. And this can happen when you have the core of the software core or the hardware at very low prices. And we all know that software is the most expensive part of building a wireless network. So if you get a software for free and then you can customize it and provide support for it, it will give you a very significant edge over the already well-established and strong vendors who are currently producing and developing telecom equipment and devices for operators. So this is Open RAN ecosystem. The Open RAN project, which was part of Telecom Infra project, and the CRAN Alliance, along with the XRAN Forum, Altogether, they form the Open RAN movement. Now, the benefits of Open RAN architecture, of course, we mentioned them, but again, reiterate them to make sure that everybody understands their importance. You have multi-vendor deployment. You can mix and match the vendor devices from the way you want, the way you like, based on your requirements and the features you want to provide in your network. Capable of reducing cost in terms of CapEx and OpEx, capable of improving network efficiency and performance, increases scalability, your systems are scalable, and you open innovation and competition in the ecosystem. Because things are going to be software driven, I will show you a company now in the coming slides, or maybe in another slide, where they built a company out of just one technique that they simulated it in terms of a function in C++, and they say that we can provide you with the advantages of this technique using just a simple software upgrade. So this is again a very amazing advantage, because in the old days I used to say that we as telecom engineers we are trained to just work as employees for big telecom companies, either operators or vendors. Because you as an individual or a small startup, you cannot build solutions that are competitive with the solutions that are currently being provided by big companies, big vendors, because you need huge investments, you need large sum of money, and not everybody can do this. But right now, with the revolution that Open RAN is making, I think this is no longer applicable anymore. Anybody with enough dedication and enough energy can enter this market and can build his own custom solutions to provide Open RAN solutions that are gonna be alternative to the existing expensive solutions. And why? Because everything is happening in software. And nowadays, even if you don't want to enter this market, you guys, anybody who develop a new innovative signal processing transmission methods or techniques that can improve the performance of the whole system in certain parameter, in certain metrics, or give better results than the existing results in the communication systems, then you will end up being able to produce a product in a form of software that you can sell it to companies who are interested in enjoying the benefit and advantage of your technique. So this is something that's really radically new and different from what we used to know about telecom networks and the telecom industry. So to sum up, the benefits are clearly mentioned in this slide. You avoid vendor lock-in, you reduce cost, you have your time to market is very short. You can build an Open RAN system in less than a week and deploy it. And you are not constrained with any vendor or limited with the innovation of any company. You can select the best of the best and work with and get his devices and software and deploy. It motivates like competition and creates innovation, speeds up innovation, and people will mostly gather in communities around the world and develop hardware or software. So these are the main advantages. But as is the case always, when you bring new solutions, when you bring new ideas, new solutions, new techniques to any field, although these solutions can bring some, can end up making you enjoy some benefits and advantages, but always they come at some trade-offs, at some like drawbacks and costs and prices. So here we want to know what are the challenges of Open RAN, what are the trade-offs, what are the some of the drawbacks that Open RAN can cause to the ecosystem of communication systems. So the first one is high front head bandwidth and low latency, reliability and availability, virtualization security, interoperability, complex automation, new hardware software requirement. Now, as you can see, all of these they seem to be challenges, but each and every challenge comes up with its own opportunities. And all these challenges, each one of them is an opportunity for a new startup, for a new company, to take this as a core responsibility for its mission and build solutions that can eliminate these challenges or avoid these drawbacks. And we have already seen many vendors, many companies working on these directions, which means that by selecting appropriate solutions from these innovative companies and the startups, you can end up eliminating these drawbacks and challenges and enjoying just the benefits that we have just mentioned regarding the Open RAN. The ecosystem business roles right now looks like what you see in the left-hand side. You have only services, support, and RAN system. But with the Open RAN, you don't have only services support, but also you have RAN software services and RAN hardware services. And in the future, in the long term, you are gonna need, on top of all of these, you are gonna need network integration, node integration, people who understand how to integrate and connect different solutions, different equipments and different hardware devices produced by different vendors and make them work seamlessly with each other. So this is new, and this transition is gonna open many opportunities, many business opportunities, many research opportunities, many ideas for people to come up and join and build their own startups, build their own companies, and take their own share of this ecosystem, which is estimated to be around in trillions of dollars. So people, as you can see, the ecosystem of telecom infrastructure is changing rapidly and developing, and as these things change, new requirements emerge, and those new requirements motivate new companies to be established and take their own share in the ecosystem. So the winners are gonna be the first movers and the ones who understand the requirements and the need of the market and just build solutions around this. So this is the Open RAN briefly, like it was founded, the Open RAN Alliance, founded in 2018. It has now more than 400 mobile network operators, many contributors, and the mission of Open RAN is about producing operator-defined network generation, RAN architecture, and interface with key objectives of the first objective is to transform radio access network and make them open, intelligent, virtualized, and fully interoperable. And second, provide flexibility to the mobile network operator to choose the best breed of RAN components. So this is brief summary. So imagine in just 2 years, this Open RAN Alliance was founded in 2018. In just 2 years, we have an ecosystem of many companies, like more than, I don't want to exaggerate, more than 60, 70 companies who are currently capable of providing you with Open RAN solutions. This is astonishing. What's more surprising is this: in the same year of establishing Open RAN Alliance, we found and we saw the emergence of new companies building fully workable Open RAN solutions within less than a year. Within less than a year. So Open RAN Alliance was founded in February. But before the end of the year, in December, we saw solutions. We saw companies having products, offering them to operators around the world. And in the next coming slides, I'm going to show you how many networks around the world have been deployed using only Open RAN solutions. And everybody is really pushing towards this and motivated to deploy and adopt these new solutions in their networks because of their many advantages and benefits that we have just mentioned. So Open RAN, another picture that explains things to us from different perspective. You start from the traditional RAN where you have closed proprietary system, no open interfaces, no interoperability, and you move on to the virtual RAN where you have you still have proprietary system, but still you get some disaggregation and partial virtualization, but no interoperability. When I say interoperability, I mean the devices of different companies are compatible, whether they are compatible with each other or not. Until we reach to the Open RAN and we have seen more disaggregation, RAN cloudifications. Now, those softwares that you are going to be building, all of them, you can host them in a cloud, system, and you provide your software solutions as a SaaS, in a SaaS method where software as a service. You might have heard about these services in the internet. You have a software that the company sells you as a service. So instead of buying and owning the software and installing it on your PC, you have this software that you can use. You can use it and pay monthly subscription fees or yearly subscription fees or whatever, but you don't need to pay the whole price of the software at once. You just pay for the software as long as you use it. And this has many advantages in the sense that you can enjoy the benefits of the software without paying too much money. And also you can access it from anywhere you want because it's gonna be on the cloud. And here you can see in the Open RAN, here you have two sides. You have the Open Radio Unit from one vendor. The green box here, you have a solution provided you from vendor one, and the orange solution you have it provided to you from another vendor two, let's say, and all of them, they can be connected to the same core network where you have open distributed unit and centralized unit, and the interface between them, and both of them are connected to the radio interface controller. So all of these are changes happening to the Open RAN. So I think we can stop here and continue our presentation, our tutorial after a few minutes. So thank you everybody. Take care, stay blessed, and see you in the next part.